Okay, conscious of time here as well, but just like to introduce myself. My name is Aoife Morrin. I'm at the School of Chemical Sciences at DCU, and I'm here to talk about how we educate in chemistry through VR. So I'm specifically going to talk about our Immersive Chem Lab project, which focuses on training of practical skills for students learning or training in analytical chemistry. So just to say that the Immersive Chem Lab project came out of some Higher Education Authority funding being developed over the past 5 years through a consortium of higher education institutes, five institutes coming together to look at innovative ways to deliver practical laboratory training to our students using digital technologies. So there's a couple of ways in which VR can very readily map onto chemistry education. And one of them that I'm not going to talk about today, but is already quite prolific in terms of apps, is how we can use VR to train or to teach our students about matter in 3D. So up until we started using VR, it was very difficult to explain to a student or to teach a student what comprised an atom, for example, in a 3D way. The other one that I want to talk about today is how we, at university level, what types of challenges we have around our laboratory training. So we know that the more laboratory training that we give, or the better quality training that we can give our students, directly correlates with their value as a graduate to Irish industry. So it's very important to us that we understand how to deliver undergraduate practical lab training in the best way possible. We're constrained, of course, by things like safety. So we have to operate within those boundaries, but we're also constrained by very, very tight budgets that we have, where we're trying to roll out laboratory practicals to increase numbers of students. Students' numbers are growing all the time, with less and less money to maintain, to invest, and to support the human resource that we need for running these labs. So just to give you an example of a module that I deliver, it's an instrumentation module, so it's instrumental analysis, where students are getting hands-on experience of up to several pieces of instrumentation. So we might have a lab running where we bring 20 students in at a time. Each of those students is operating a different piece of equipment, which is complex in nature. So we need resource then to run all those instruments to support the education of those students as well, all while we're running some of these quite chaotic laboratories in a safe manner. It tends to be, as I said, quite resource heavy. We have a rinse and repeat model where we've 20 students in on a Monday doing those 20 different experiments. Same again Tuesday, same again Wednesday, and so on. So huge resource goes into the delivery of these practical modules. And one of the consequences is that we tend to need to be quite procedure driven. So students follow quite rigorous procedures in the lab. And there's little time for exploration or inquiry-based learning, because this is the first time they're seeing these instruments in the lab when they walk in. So we're expecting a student in 6 hours to understand an instrument, be able to interact with the software to control that instrument, and to generate some meaningful data. And that's quite difficult in a 6-hour lab. So our use case for immersive technology at DCU has been to use VR to prepare our students for that face-to-face training or practical training session, so that they can make the most use and be most efficient during that time. So if we can have our students understanding an instrument, having run through the software before they come in, we can start to think about enabling a lot more inquiry-based learning and exploration. So we see that increased preparedness, the more we can prepare our students, the greater the confidence the student can have, and therefore the better learning can be gained during that experience. So this is one of our instruments that we use. It has lasted the test of time. It probably is an early 80s purchase by DCU, probably one of the first. And what we did was try to develop this out as a more modernized version in VR. What was important to us when we were developing this out is that the student would interact with this instrument in exactly the same way as they would when they come into the lab. The other thing that we wanted to ensure was the students could perform analysis, sample analysis with this instrument in VR and generate data in real time so that they can visualize really what's happening within the instrument. So this is a video of the Immersive Chem Lab app. So we've got 4 modules in the app where we are showing the student, introducing the student, or navigating the student right through the instrument before they come into the lab. We're giving them procedures, we're giving them theory, and we have built it out in exactly the same environment that the student will come into when they come into the lab. So one of the things that we've built in is additional information, but also some animations so that the instrument itself is no longer just a black box that the students see when they come into the lab, and they can understand the mechanics of it and what's going on. Okay, so how do students like Immersive Chem Lab? What do they say? Well, just in the interest of time, we surveyed the students and we focus group the students. And really what they say was, one student said to me, the experience is exactly the same as it is when I go into the lab. So therefore, I already know what I'm doing before I go into the lab and I can learn more. So the overwhelming response to their experience in Immersive Chem Lab, increased familiarity, increased confidence, increased efficiency is really important. So the students are getting through the work quicker. So that opens up room for this inquiry-based learning that we can add and deeper learning outcomes that we can affect in these environments. Better understanding of the chemistry at play, and they enjoy it more, which of course is allows them to learn. If somebody's enjoying something, they learn more. So just to say that this is to be continued, we're developing out additional experiments in this environment where we see it being used as a complement to physical labs. But in some settings, of course, universities don't have access to all equipment, and we're exploring this as a replacement for some of the experiments that students need to train on. Just to say thanks to the people that are involved. Shout out to Gary, who's here from Fourth Reality, for enabling all of this. And finally, we wouldn't be able to deliver this kind of training in DCU without the capacity, and we have several rooms that are kitted out and technically supported for delivering this kind of education right across the campus. So that's me. Just want to say thank you. And yeah, look forward to the rest of the day. Thanks very much.